come in the room, come in the room. Today I am here with another video. So you can come on in and let's talk about math. Math tutoring on demand today is a way for you to get all your questions answered. And I'm here to answer them. So, if you don't already know, I'm Stacy and I'll be your math tutor today. All right. So, without further ado, I'm going to move on over and share my screen to Clucky. That is my means of showing you my whiteboard, um, so you can get all the good information online. And in this form, I'm going to have you answer and ask questions. I'll answer them with practice problems. I'll even ask you questions. Just put your questions in the chat and we'll get started. All right. Okay. So we haven't got anyone on just yet. So we're just gonna wait a few moments to see anybody chimes in. And while I'm waiting on that, I'm just gonna prepare my whiteboard a bit. Um, and I'm going to say import. I'm gonna import I think I'm gonna, I'm gonna import this picture as an image. Okay. And I just want to cover up this math tutoring on demand so that we can see the whiteboard more clearly and get some things going. Okay, so I'm going to my paint bucket, but hold on. First, I need to select, right? I think. Okay, let me just create a one. Whiteboard, and I'm going to fill it. Hydro. And like I said, I'm still learning this tool from the last session. So that's kind of was my first playing around with it. But as I learn more and more and get better and better, you know what I mean? So I'm going to see if I can feel the shape of them. I'm trying to see. Oh, I see what the eyedropper does. But that's what I want. So basically, the eyedropper kind of collects the shape. Mm, Okay, let me see if I can do this. I'm gonna select the white. There we go. All right, that's it right there. Okay, good. So let me go back over to the chat and see if I have anybody on here. Yay! Now we see my whiteboard is that's where we're gonna do all our great work and things, all things math. And so today, while I'm waiting, um, every time I'm waiting, I'm gonna talk to you a little bit more about my book, Primordial Race. Um, and so I will go back to the whiteboard And I'll check back from time to time and see if anybody's on. But for right now, we're going to talk about primordial race. Okay. All right. So let me get my brush. And let's talk about primordial. Oh, wait. Okay. Since it's white, I got to change it back to black so y'all can see what I'm writing. Primordial race. Now, does that look like an L to you? Let's take that back. Okay, so what primordial race is, and I probably should have typed it. I could have typed it. Um, it's really a book about the prime versus composite dilemma. Not really a dilemma, or phenomenon, right? So we have what a primordial is really is the product of prime numbers up to a point. That so like P sharp. Okay, P sharp is the P and the pound sign and the hashtag. The P is a number. So if I say 7 sharp, then you would that's equal to 7 times 5 times 3 times 2. Okay. If I said if I say 11 sharp, then it will be 11 times 7 times 5 times 3 times 2. I mean, you really can't go too far unless you really know your prime numbers. So P is a prime number. P is a prime number. So all the prime numbers, the product of all the prime numbers less than P. Okay? Primes less than P. I'm gonna put a half. I'm gonna put an asterisk. So multiply primes less than P. That's what a primordial is by definition. Okay. So that when I say primordial race, we're gonna talk about this race to primes or race to infinity. When we start seeing these numbers get larger and larger, right? So the primordials get bigger and bigger really, really fast. Okay, so let's go ahead and go back to the board and let's do a dimensional analysis. So last time I put the dimensions. I wonder if I can type it and then rotate it. You know what? I'm gonna try that so my graph comes out a little bit better. Okay, so how about we do a text and I'm gonna put dimensions and then I'm gonna see if I'm gonna say okay and see if I can rotate. Oh, oops, cancel. I don't think I can select it and rotate it, but we're gonna see. Maybe. Unsave worked. Okay. want to share. Uh, anyway, okay, so we're back to 100. But I'm going to undo the dimensions because I couldn't rotate it. And I'll do 1, 2, a 3, 4, 5. I'm not going to do above 5 right now. Okay. So we'll say 5. And this is 1. And then we'll go 1, 2, 3. Now we start at 1. So what I'm going to do is kind of put this like we're not starting at 0. So we're going to start. I don't know. Can you tell that that's a broken graph? Okay. Let's just start from 10, 11, 15, 16, 17, 18, 19, 20. So we'll do 10 today. Okay. So say for instance, this is our kind of like our broken graph where we start at 10. And then at 10, we're going to say 10. If we look at our factor tree for 10, we know that it's just 2 and 5. That's the only way you can break it up is by dividing it by 2, and it's 5 groups of 2, right? So that's it. That means it's at the level 2. So it's a 2D number, okay? Then I'm going to see if I can erase. I don't know that I can erase, but I can fill with a line. Okay, so that's completely white. Oh wow, that's really bright. I don't think I did it like that last time. That's still dark. Okay. Well, okay. Anyway, 10 is a 2D number. 11 is a prime number, so it's on 1. It's on level 1. All prime numbers are level 1 because they cannot be broken down. So then we really go back to black. Put it on 1. Then for 12, 12 is even, so it's 2 and 6. And 6 breaks down into 2 and 3. So that's 1, 2, 3 prime numbers make up 12. Right? So that's going to be the third dimension for 12. It's a 3D numbers on level 3. Okay. Then 13 is prime. So it's on level 1. 2 because it is 2 times 7. 15 is 3 times. Those are 2 prime numbers, so it's on level 2 also. And then 16, let me go ahead and erase this. Oh, okay, that's nice. Okay, so yeah, that's more like it. So now we know it's like right there. Okay, so 16 is, let's go back to black. Let's look at the factor tree for 16. It's even, so one of the factors is 2. It's 2 times 8, right? Because half of 16 is 8. And then 8 is 2 times 4. And then 4 is 2 times 2. Okay, so we can't break it down anymore. So it's 1, 2, 3, 4. It's in the fourth dimension because it's the root of 2 times 2 times 2 times 2. So that being said, we're going to go on over. I'm going to erase this right here. And okay, we're going to erase that right there. And then we're going to put 16. Let me just erase all of that. We'll erase it and then we'll go back to our brush and black. And then we're going to say 16 is a 40 number. So it's way up there on level 4. Maybe a little lower, but you get it. Let's see, level 4, 16. Okay, so that is where we're at on that. So this is the dimensions and these are the numbers. And so the first thing we're going to look at now, or the next thing I should say, is 17. 17 is a prime number, right? Since a prime number is down on level 1, and then 18 is the next number. Let's look at the factor tree for 18, which is 2 times 9, and 9 is 3 times 3. Okay, so that's 1, 2, 3 dimensions. So we know that this is in the third dimension. Okay, and then 19 is prime, so it's down on level 1. And 20, let's look at 20. 20 is even, so one of the factors is 2, and the other factor is 10. 2 times 10 is 20. 10 we did earlier is break down into 2 and 5. So that's 1, 2, 3 prime numbers make up 20. So that's on the third level, level 3. Is that 3? How many numbers do I have on level 3? This is level 3. This is 3, and 20 is on level 3. Okay. So these are the level 3s. That's a level 4. All right. So now we get to connect the dots. Well, let me connect the dots and then I'll erase the factor trees. So starting at 10, let me get another color. Starting at 10, we're going to go from 10 to 11. We'll go down to the first dimension. Then we'll go up to the third dimension. And then we'll go down to the first dimension, up to the second, stay on the second, and then go up to the fourth dimension, down to the first, up to the third, down again to the first, and then up. All right, so this is our little dimensional graph from 10 to 20. And so this is one of the things, it's dimensional analysis. And we figure out what dimension these numbers lie in just by their factor tree and telling how many prime numbers make up that number. Okay, so that's it really. For primordial race, talking about that. Okay, so the more we know about the number, the better we can do different types of algebra, geometry, you name it. But knowing that they are how they're related and how they move through the dimensions is helpful. Okay. Let's see. I think that's pretty much it for now. Right now, I'm not gonna stay on here too long since I haven't gotten anybody. But tomorrow, our next session will be tomorrow. We are gonna go live with one of my students at 2 p.m. So we're gonna do oopsies. Let me do let me do this. I will cover this up. Okay, and then I'll say next session. Okay, so next Tuesday at 2 p.m. I want to thank you for tuning in. If you are watching this on the rebroadcast, then like, subscribe so you can know when we're coming on next. You'll see the little live indicator let you know that we are um, the online tutor house is on and that I'm doing a live presentation. 9 times out of 10, it's going to be a live tutoring session. Okay, so um, subscribe so that you could get notifications and everything for our next math on demand. Okay, so I got a special request for tutoring on Wednesdays at 2 p.m. and we'll be right back here. All right, thank you again, and we'll see you next time. Bye.